Hello, my people. Today is chemistry. We're going to talk about mole concept. And one thing about chemistry, if you want to crack chemistry very well, you need to know the names of the elements, their symbols, atomic numbers, their IPAC name, how to balance chemical equation, how to configure them, their valency also. Because some equations will be just right, some questions will be just right for you to find, for you to write the equation and also balance the equation. So if you don't know their IPAC names, it's very difficult for you to solve. Sometimes when you want to weaker students, so they will just write it. They will just write the question. They said write the equation and balance the equation. So if you don't know their IPAC name, you're not able to solve. And if you don't know how to balance the equation, you're not able to solve also. And if you don't know their atomic numbers, you're not able to find their molar mass. So all these things, you need to know them. You need to know how to configure them. Sometimes they will ask you their configuration in ground states. All these things they need to ask you. But as we are going, we are learning bit by bit. I have some questions here today that are going to solve under mole concept. And one thing about mole concept, when they give you the molar mass, they give you the mole. They say find the gram. When you're finding the gram, the mass of the gram of the mass, you said mole times molar mass will give you the gram. But when they give you gram, they give you molar mass to find the mole. Mole is equals to mass in gram divided by molar mass. You will have the mole. And sometimes again they will say give you amount, for example, say the amount of oxygen or the amount of chlorine, that amount of atom, like that, the amount of atom, that is the Avogadro's number. And Avogadro's number is 6.02 times 10 raised to the power 23. Anywhere you see, they say give the amount atom or a amount molecule. Anywhere you hear amount is Avogadro's number. Because Avogadro's number deals with the amount of molecules, amount of atom, etc. Whenever they say find the amount of atom, the amount of molecules, that is Avogadro's number. They are asking you to use the Avogadro's number by the times the mole for you to have the amount of the atom or the molecule. But as we are going bit by bit, we understand. So these are the things you need to know. When you know these things in chemistry, calculation will be easy. It will be so easy for you. So let's start now. So let's see this one. For example, question 1, mole concept. They say calculate the number of chlorine atoms contained in 0.20 gram of DDT. So this they say the number of chlorine atom. As you see this atom, that means Avogadro's number they are asking for. Avogadro's number, but you cannot go direct to solve to find the number of atom if you don't know the mole or the mass or the molar mass or the gram. So this, wherever we go, we need to, this is the equation they give us. This pentachlorobenzyl chloride pardon me, C14H9Cl5. So I'm going to find first the molar mass of this one. From there we solve. That's the solution. So let's say C14H9Cl5. So it's equals to C is 12. C is 12. Let's say C is equals to 12. H is equals to 1 and Cl is equals to 35.5. So from there now we can able substitute this one here. Okay, the here they already give us. Look at this here, so I'm sorry. So let's continue. So now 14 into 12 brackets close plus 9 into 1 plus we have oxygen chlorine is 35.5. Yeah, they give us 5 multiplied by 5. So let's calculate it now. I'm using it so because yesterday I was finding it difficult to show myself on the paper. I was finding it so difficult, so that's why today I decided to do it this way. I've already did the presentation, so it's not my face you need to see, but what I'm doing is what you need to see. Yeah, so that's why I hold the camera like this. So 14 times 12 give us 168 plus 9 plus 35.5 times 5 give us plus 177.5. So let's add all things together now. We have 168 plus 9 plus 177.5. So we have now 354.5 gram per mole. Now we have the molar mass. This is the molar mass. So let's solve now the equation. We have found the molar mass of the equation. So now let's find the mole. So mole of C14 H9Cl5 is equals to mass in gram upon molar mass. So here I will say the gram of the mass here is, look at 0.20 gram. So 0.20 gram divided by this molar mass we have now, 354.5 gram per mole. So gram cancel gram. So let's solve now because we are finding mole, it's not gram we are finding. So 0.20 divided by 354.5. So this is the, so we have now the mole now. Mole is equals to, let's say 0.20 divided by 354.5 is equals to, this is what we have. We are going to, because to say it goes to 10 times 10 raised to the power minus 4, 0.4. So our answer is now 0.12340. I'm taking out the decimal, the number for it. So now 564. So 564 mole. So now we have solved for the mole. So let's find out Avogadro's number, because I say number of chlorine atom. So we're going to find out the number of chlorine atom. So let's find chlorine atom. So Cl5 is equals to 0.00564 times 5, because we have 5 chlorine here. So it will give us now 0.00564 times 5. It will give us now 0.00282. It was 0.00282 mole. So now we're going to find out Avogadro's number, the atom of chlorine. Atoms of chlorine is equals to now 0.00282 times 1.6 times 10 raised to the power 23 mole. So when you multiply it now, let's say 0.00282 times 1.6 so we have 4 points. So we have 4 points 512, 4.512, but here we have, yes, it's a times 10 raised to the power minus 3, and Avogadro's number we have 10 raised to the power 23. So when you remove the 3, it will remain 20. So it's now times 10 raised to the power 20 mole. And you remove it to give you this answer. So now let's go to the next question. The next question says, calculate the number of atoms in 18.5 grams of manganese metal. So now let's find the number of mole. But first, we're going to find first the mole. From there, we find the number of atoms. Here we have gram. That's a solution. Mass in gram is equals to 18.5 gram. Okay. Molar mass is equals to 24.3 gram per mole. And Avogadro's number, AN just got short like this. Avogadro's number is equals to 6.02 times 10 raised to the power 23. So let's find the mole. Mole is equals to mole. We don't know the mole, so we're going to find mole. So now we say mole of manganese is equals to mass in gram divided by molar mass. So let's go. So the mass in gram is 18.5 gram divided by the molar mass is 24.3 gram per mole. So gram cancel gram. So let's solve now. Say 18.5 divided by 24.3. So we have now 0. As you can see, we have 0.7613 blah blah. We consider 0.76 0.76. Consider 0.76 mole. So now we have mole, so we can solve for the amount of atom. So atoms of manganese. Atoms of manganese is equals to now mole times Avogadro's number. Just make it short like this. So the mole is equal to 0.6 mole times 6.21 times 10. Sorry, let's maybe write it over here. So 0.76 mole times 6.02 times 10 will say power 23. So let's calculate it now. So we have now 0.76 times 2.02 0.76 times 6.02 give us 4.575. We're going to round it up. So we have 4.5752. So we're going to round when we round the 5 to the 7, it will become 8. So we're going to write now 4.58. Okay, 4.58 mole. So we have done with this one. Let's go to the next question again. So they said if 3.08 gram of fluorine completely reacts with 50.0 cm cube of 2.20 mole dm cube of HCl. So I say write an equation for the reaction. So they say there's a solution, SOLUTION, solution. So we have fluorine plus HCl. So react now to give us when this reacts, this and this one will come together and this remain. I hope you understand. So this one will remain. So when it reacts, I will say now FeHC plus H2. So now we have 2H here, and here we have 1H, so we say 2. When we have 2H here again, here we have 2H, here we have automatically these two we have fixed to have 2 chlorine. Now the equation is balanced. We have balanced the equation. But let me write the unbalanced equation, so for you when you are going over, you understand. This is a balanced equation. Balanced equation. So this is balanced. The one that was not balanced. So let me rewrite it again. So when you are going to do the video, you will understand. Let me write the unbalanced equation. Well, I'm supposed to write the unbalanced equation first before I balance it, but pardon me please. It has to give us FeCl plus H2. So this is the unbalanced equation. Unbalanced, please. I'm supposed to write this unbalanced and later write this balanced one. But please pardon me. So let's go. So now we have this one, and they said we have this in 50.0 cm cube. This one is in cm cube, so we need to convert it in dm cube because it said react to it 50.0 cm cube of 2.20 mole dm cube. So we need to convert it to dm cube. So this we divide it by 1000. So 250.0 cm cube divided by 1000 cm cube, divide it by dm cube. So let's just leave that. So times 1 dm cube. So cm cube cancels cm cube. So let's divide this one and see what we have. So we have 50.0 divided by 1000. So we give us 0.05. So we have 0.05, then times it by this dm cube. So we have converted this one. So let's solve it now. So for this one, since it's dm cube, so we are dealing with volume here. So the equation that we need to use is mole of fluorine is equals to concentration times volume. So now mole of fluorine is equals to, this is stand for concentration times volume. So the concentration that we have is 2.02. So the concentration is 2.02 times now the volume is what we convert here, is this one in dm cube. So 0.05 dm cube. This one also is in mole per dm cube. So here we are looking for mole. This is mole per dm cube. Let's match it down. Mole per dm cube. So dm cube cancels with dm cube. So remain with mole. So let's times this one. So 2.020 times 0.05. We have now we have 0.11. So this one is equal to 0.11. But here we have 2 moles of fluorine give us, but here we have 2. So we have, so let's find the when it reacts with HCl, and here we have 2 HCl. So we take the 2 and divide it by this number to have the final mole. So it's equals to 0.11 divided by 2. So it's equals to now 0.11 divided by 2. It gives us 0.055. So we have 0.055 mole. So we have this now. So let's find out the relative atomic mass. So relative atomic mass is equals to mass upon molar mass. So now say Ra is equals to mass upon mole. Sorry, not molar mass. Mass upon mole. So the mass they give us, look at the mass here. The mass is 3.08 gram. So we say 3.08 gram upon this one we have here, the mole, which is 0.055 mole. So now let's divide and see. So 3.08 divided by 0.055. So it will give us 56. You can see give us 56. Give us 56. So it's equals to relative atomic mass now is equals to 56 grams per mole. So this is the answer we have. 56 grams per mole. You can see. This is what we have. So let's go to the question 4. What question 4 say? Say 2 moles of propane reacts with 8 moles of oxygen gas in a combustion reaction. 1. Say write a balanced chemical equation. So let's write the equation. So let's say propane is C3H8 plus O2. When it reacts, it will give us CO2 plus H2O. This is unbalanced. I don't want to do the same mistake like the first one. This is unbalanced. So let's come and balance the equation now. So C3H8 plus C2 reacts with CO2 plus H2O. Fine. Yeah, how many? We have carbon 3, and here we have carbon 1. So we need to have 3 carbon here. So carbon 3, carbon 3. We have done with carbon. Now let's go now to hydrogen. We have 8 hydrogen here, but here we have 2 hydrogen. So for us to have the exact number, we're going to say 8 divided by 2 will give us 4. So we write 4 here. So now we have 8 hydrogen here, 8 hydrogen here. Hydrogen is complete. Let's go to oxygen. Let's go to oxygen now. Oxygen, automatically this 3 that stand in front of it affects the oxygen also. So 2 times 3 is 6. We have 6 oxygen here, and here we have 4 oxygen. 4 plus 6 is 10, right? And here we have 2 oxygen. So let's say 10 divided by 2 will give us 5. So write 5 here. So the equation is balanced. Balance. So we have balanced the equation now. So let's go now to the proper solving. I even don't write solution, sir. Solution to separate it. So now they said we have write the equation. And so now how many moles of carbon dioxide are formed? So said how many moles of carbon dioxide are formed. So going to say that we have here 2. How many moles of carbon dioxide are formed? But here they said 2 mole. So 2 moles of propane. So we have, let's write now, 2 moles of C3H8. So here, when it's reacts, here we have how many we have here? We have 3 mole of this one. So we said times 3 mole of CO2, all divided by 1 mole of C3H8. Fine. So as you still have this and this cancel. So 2 times 3 is 6. So now 6 divided by 1 is same as 6. So now we have 6 moles of CO2 is formed. Is formed. Is formed. So we have done with this one. We have done with question 4. So now let's go to question 5. Let's look at question 5. It said, to prepare a vaccine for COVID-19, a pharmaceutical engineer dilutes a stock solution of fluoric acid by adding 25.0 cm cube of 7.50 m acid to enough water to make 500.0 cm cube. And here they said, what is the mass in gram of fluoric acid per millimeter of dilute solution? So let's find the solution. Now for the solution, let's take first this one, 225.0 cm cube. We divide it because the answer we want in dm cube. We want to answer in dm cube. So we say now 25.0 cm cube upon 1000 cm cube times 1 dm cube. So this and this goes together. So the remaining one we divide because we are looking for, let's say, in liter, milliliter. So this is in cm cube. So we need to convert it from dm cube. From there we continue to solve. Said now, so 25.0 25.0 divided by 1000 is equal to 0.0525. 0.025. dm cube is the same as liter. So here we say liter, because dm cube is equal to liter again. Same in liter. So say 1 liter. Let's solve now for the equation. The concentration, we have concentration. So we're going to say concentration times volume. So moles of what the equation they gave us. They were finding the mole of H2SO4. I forgot to write the equation. Hey, trouble. This is sulfuric acid. Then it had water to it. So this is what we have. So now the substitute now, say concentration times the volume. So here we say now the concentration is 7.50. It's the same as, because this was the same as milliliter. The M represents the same as millimeter. So liter times what we have here now, 0.025 liter. So liter cancel liter, means mole. So let's times and see what we have. It says 7.250, times 0.025. As you can see. I don't know if you can see it. As So you can see it now. You can see. I miss 0.2, miss. So that's 7.5. So 7.50 times 0.025. So now we have 0.1857. That's 0.1875. So we have 0.1875. That's 5775. Sorry, mole. So we have this one. Let's go to the other one. Let's find the mass. So mass now, mass of H2 SO4 is equals to now mole times molar mass. So it's equals to now, the mole is 0.1875. And the molar mass of this one, hey, we're going to, let's scatter it to find the molar mass. The molar mass of this one, let's say H is 1, fluorine is 32.07, oxygen is 16. So let's solve now. Let's say 1 times 2 plus 32.07 times, okay, plus, because it's equals to 1, plus 4 times 16. So this is 2 plus 32.07 plus 4 times 16. 4 times 16. 64. So 64 now plus 32.0 plus 2 is equals to, so equals to 98. So 98.0 gram per mole. So yeah, times 98.0 gram per mole. This is mole. So mole and mole go. So it's because we are finding in gram, not in mole. So we have now 0.1875 times 98.0. So it's equals to now, this is what we have 18.375. So we have now 18.375 gram. So now let's find the concentration. So find the concentration. So let me see now, conc is equals to, so this we are finding the gram. So this is the mass in gram upon what we the, let's say, to enough water to make 500.0 cm cube. So that is the something like a volume. Yes, volume is the same. 500.0 cm cube is the same as 500.0 milliliter. It's the same. So this is the volume. So now we have the mass in gram here is 18.37 upon. We have 500.0 milliliter. Now it's not again cm cube because it's saying milliliter. So let's divide and see what we have. So 18.37 divided by 500.0. So it's equals to 0.0367. We may leave the 0.0367. Let's consider the the 4 numbers after the decimal points. So we have done with this one. So let's move now to the final one. So here we're going to stop for today. Question 6. Calculate the vapor densities of the following gases from the given data. So we have 560 cm cube of oxygen at standard temperature STP, and we have the other one 1400 cm cube of fluorine 4 has as oxide. So let's continue. So let's write solution. Let's continue. Solution. So let's take the first one. 560 cm cube of oxygen 2, but this we're going to convert it. I'm not to use it directly like this. We're going to convert it to dm cube. So we say 560 cm cube divided by 1000 cm cube times 1 dm cube. So this and this goes together. So the answer we have here 560 divided by 1000. It gives 0.56 dm cube. So now when we are finding, let's have that in mind that vapor density is equals to half the molar mass. But going to pause first. Let's find the mole first. Let's find the mole. Mole of oxygen 2. So it's equals to volume in dm cube upon molar mass, molar volume upon molar volume. So now let's go. The volume now we have is a 0.56 dm cube upon the molar volume, which is at standard temperature, so it's 22.4. They say at standard temperature, so 22.4 dm cube. So dm cube cancel dm cube. So Let's calculate now. Okay, 0.56 divided by 22, 22.4. So I have 0.025. So the answer is equals to 0.025. And what they said we should find it, we will find moles. So it should be moles. Fine. So now let's go to standard. Let's find out the vapor. Let's find the molar mass. We are finding the mole. Let's find the molar mass. Molar mass. Please pardon my handwriting, please. Molar mass now is equals to gram. This is 0.4. The gram they give us here. Gram in mass 0.8 gram. 0.8 gram upon the mole which we have now 0.025 moles. So when we divide this now, we see what we have. So let's divide it. 0.8 divided by 0.025. I have 32. So say 32 gram per moles. So we have this one. So now let's calculate for the vapor density. So Vd now is equals to half molar mass. So this one, when you divide this together, so 32 divided by 2 is equals to 16. But let's prove it. So then say I don't use calculator. Right, 32 divided by 2, 16. Here we have 16. So let's go to the last one. And so to give us 1,400 cm cube of fluoride for oxide. Fluoride for oxide weight 4 gram. Fine. The same thing we did for the first one is just the same thing we're going to do here. So say 1,400 cm cube upon 1,000 cm cube times 1 dm cube. So this and this go. So remain now 1,400 divided by 1,000, 0.4. So we have 0.4 dm cube. So we're going to substitute it now to find. So as you can see here, we said volume upon molar mass when we are finding the mole. So here also we say mole is equals to volume upon the molar volume. So 1.4 divided by dm cube divided by 22.4. This is a standard temperature 0.3. So this and this going together. So let's divide and see what we have. So 1.4 divided by 22.4. We have now 0.025 0.0625 moles. 5 moles. So we have this now. So let's find out the molar mass. So molar mass of SCO4 is equals to, they give us the mass in gram. The mass in gram, which is 4, look at the weights, which is the mass in gram, that is the weights, upon this one, the mole, 0.0625 mole. So let's divide now. So 4 divided by 0.0262, so it gives us now 64 gram per mole. 64 gram per mole now, and we say vapor density is equals to half the molar mass. Half the molar mass. So 64 divided by 2. That's what we have. 64 divided by 2. We have 32. We have 32. This is our answer. Thank you very much.